Hello everyone and welcome to our universe. Today, we will be answering the question, what is astronomy? Define astronomy. By definition, astronomy is the study of things in the sky, like the sun, the moon, the stars, galaxies, and stuff like that.
The universe was born with the Big Bang as an unimaginably hot, dense point. When the universe was just 10 to 34 seconds or so old, a hundredth of a billionth of a trillionth of a second in age, it experienced an incredible burst of expansion known as inflation, in which space itself expanded faster than the speed of light. At this time, all matter was compacted into a very small ball with infinite density, an intense heat called a singularity, based on Einstein's theory of general relativity. Suddenly, the singularity began expanding and the universe as we know it began. A key part of this comes from observations of the cosmic microwave background, which contains the afterglow of light and radiation left over from the Big Bang.
Light chemical elements were created within the first 3 minutes of universe formation as universal expand temperature called the neutron collide to make the deuterium, which is an isotope of hydrogen. Much of this deuterium combined to make helium about 800,000 years after the Big Bang matter cold enough for electrons to combine, which nuclei form natural atoms. This phrase is known as recombination and absorb the free electron cause the universe is become transparent. The light that was unleashed at this time detectable today is a form of radiation from cosmic microwave background.
First off, there weren't always stars in the universe, and the Milky Way hasn't been around forever. After the Big Bang happened and the universe cooled for a bit, all there was gas uniformly spread throughout. Small irregularities allowed the gas to coalesce into large enough clump, heating up and eventually starting the nuclear fusion that powers stars. Not all of the stars in the Milky Way date back to the primordial universe, though. The Milky Way is often referred to as a cannibal galaxy because during formation it allowed up smaller galaxies. In fact, the Milky Way is clearly gobbling up another galaxy at this very moment, called the Canis Major Dwarf Galaxy. The remnant stars are 45,000 light-years from the galactic center and a mere 25,000 light-years from our Sun.
Where do stars come from? Every star forms in a huge clouds of gas and dust. Over time, gravity causes a cloud to contract, drawing the gas closer and closer together. As more gas accumulate at the center, it becomes denser and pressure increase. This causes it to heat up and begin to glow. Its gravity continues to pull in gas and temperature.
First star in the universe may have been extraordinarily fast spinning, whirling at more than a billion miles per hour. First stars called spin stars, from right after the Big Bang 13.7 billion years ago, and were likely massive giants, with 8 times more than mass of our Sun. According to the new study, the life fast and died young after no more than 30 million years. This star also provided the universe with its first element heavier than helium, A 12 billion years old global cluster of stars known as NGC 6522 provided the basis for the proposal of spin star. NGC 6522, the oldest known as globular cluster in our galaxy, probably witnessed the early phases of the seedings of this heavy element across the cosmos. However, a study of light from this cluster star, which revealed with element lie within, yielded contradictory evidence about the nature of the first star.
A massive concentration of interstellar gas and thus created a molecular cloud that would form the sun's birthplace. Cold temperatures caused the gas to clump together, growing steadily denser. The densest parts of the cloud began to collapse under its own gravity, forming a wealth of young stellar objects known as protostars. Gravity continued to collapse the material onto the infant object, creating a star and a disk of material from which the planets would form. When fusion kicked in, the star began to blast a stellar, and that helped clear out the debris and stop from the falling inward. After the sun formed, a massive disk of material surrounded for around 100 million years. That may sound like it more than time for the planets to form, but in astronomical terms, it's an eye blink. As the newborn sun heated the disk, gas evaporated quickly, giving the newborn planets and moons only a short time amount of the time to scoop it.
Open Sun, the star around which Earth and other planets orbit, it provides heat and light to Earth. It has a mean distance from Earth. It has a mean distance from Earth of about 150 million kilometers and a decimeter of 391 kilometers and a mass about 333,000 times that of Earth. The Sun is by the largest object is a solar system, containing more than 99% of the latest total mass. Observation of other stars indicate that the Sun is very normal. It has a mass virtuosity and the temperature that is somewhere in the middle to how and of the observed spectrum. The Sun is mainly composed of hydrogen and helium.
According to this theory, the Sun and all the planets of our solar system began as a giant cloud of molecular gas and dust. Then, about 4.57 billion years ago, something happened that caused the cloud to collapse. This could have been the result of a passing star or shock waves from a supernova, but the end result was a gravitational collapse at the center of the cloud. From this collapse, packets of dust and gas began to collect into denser regions. As the denser regions pulled in more and more matter, conservation of momentum caused it to begin rotating, while increasing pressure caused it to heat up.
When it comes to the formation of our solar system, the most widely accepted view is known as the nebular hypothesis. This theory states that the Sun, the planets, and all other objects in the solar system are from nebulous materials billions of years ago.